Okay, so what we're going to be looking at here is we're going to be proving different relationships from the properties of the quadrilaterals that we looked at using the coordinate plane. Okay, so we're going to be either be given an image with the coordinate plane, and we want to complete the image, or we're going to be given a set of points, and we want to be able to show which one of those quadrilaterals are we dealing with, and that's based on the properties of the quadrilaterals that we looked at before. And specifically, we're going to be using the slopes and distances using the distance formula to help us determine the relationship between the sides, and then also the relationship between the slopes. That way we can determine which quadrilateral we're looking at. Now, to kind of introduce us into this topic, if we already know some of the points and we're to plot them like they have A, B, and C here, we can determine the missing point by just recognizing what we're dealing with here. They tell us that we have a rectangle ABCD. Now remember, a rectangle, opposite sides will have the same measure, and then also they'll be parallel to one another, but we also have 90 degrees. In other words, our adjacent sides, for instance, like A, B, and B, C, they're perpendicular to one another. They form a 90-degree angle. So A, B, and B, C over here are going to form a 90-degree angle. And we can use that to help us finish the image. For instance, I know that AB's length, that measure should be the same thing as our missing side to find D. Okay, so if this is 1, 2, 3 units, then this also better be 1, 2, 3 units. Okay, and notice, because this adjacent side that we're claiming this is our D here is perpendicular to our C, that also meets our idea for the relationship of a 90-degree angle both here, and then also connecting AD, we also form a 90-degree angle there. So actually I kind of misstepped my side here, but we'd have our side here and then here. Okay, and that's kind of what they show over on this side here. It says we can use the knowledge of adjacent sides, like we talked about, that have perpendicular slopes, and opposite sides must be equal. Okay, they're equal in measure. Okay, so CD was 1, 2, 3, just like AB is 1, 2, 3, and then also we have our 90-degree angle formed by our perpendicular lines. Okay, similarly, I forgot to write the point. This is the point. It looks like 4, 4. Okay, so this is the point 4, 4, so that's what's D. Now let's move on to this next picture here. We have the parallelogram ABCD. So remember, with a parallelogram, that's very, very basic. Okay, it's not as specific as a rectangle or a square or even a rhombus. All we really need to be concerned about is that the sides, opposite sides, are parallel to each other. Okay, and that we also have our opposite sides have the same measure. Okay, now they don't have to be perpendicular, we just need to have the same slopes between our sides. Okay, for instance, notice, to go from B to C, I have to go up 2, that's my rise, and my run is 2. So to go from B to C, I have to go up 2 and right 2. So D, I would have to go from A, up 1, 2, right 2. This guy over here should be my D, okay? We have the same slope here between AD and BC, okay? So my sides there, AD and BC, would be parallel because we have the same slope. And then because that guy is parallel, this guy is going to be parallel too. It has the same slope as AB. And notice the measures are also going to be the same, okay? We went up and over by the same distance, so the measures are going to be the same as well. Okay, now it says we know, just kind of briefly talking about what I said here, we can use the knowledge that the opposite sides must have parallel slopes and must also be equal. So that helps us to determine the location, which we found that D was 2, 2. So our D was 2, 2. Okay, now that's for given examples that look like that. Let's go ahead and look at some more complicated ones. Okay, now there's 2 different methods here, so it's going to take a little bit to kind of look at both of the methods here. But what this is they're going to give you a set of points. So they're giving you A, B, C, D, but we have no idea what it looks like unless we actually plot the points. And we want to prove, using those points, specifically what the relationship between the sides are and the slopes are and the distances, those measures of the sides, so we know specifically which quadrilateral we're looking at. Now the first method, they say, is we can look at the opposite sides to determine if they're parallel. Well, we would know if they're parallel based on their slope. Okay, so we're going to use the slope formula between those 2 points that form that side to figure out what the slopes are going to be. And if the slopes are the same, they're parallel. Okay, if they're not, then they're not parallel. And we just have a quadrilateral. It wouldn't be a parallelogram if we don't have opposite sides that are parallel. Okay. Then also, if the adjacent sides are perpendicular. Now, if they're perpendicular, that's nice because that tells us we're either going to be dealing with a rectangle, and I'm going to abbreviate that, or a square. Okay, because remember, a rectangle and a square have 90-degree angles. Okay, now if all the sides are equal, that would be a square if it's 90 degrees, or if we didn't have 90-degree angles, that would be a rhombus. But if all the sides are not equal, then that would have to be a rectangle. Okay, so if all the sides are not equal and we know we have 90-degree angles, okay, that would have to be a rectangle. Okay, now method 2 here says diagonals are congruent. Now, if diagonals are congruent, we know we're dealing with either a rectangle or a square. That in of itself tells us that we're dealing with a rectangle or a square because those guys have congruent diagonals. Now, if all the sides are the same, that would be a square in that case. If they're not the same, if it says all the sides are not equal, again, that we'd be dealing with our rectangle. Okay, so that's what they're giving us here. So it says, for instance, what if we have ABCD is a rectangle? Okay, so if we have a rectangle here, let's just kind of draw one out. Let's say this is A, to kind of visualize this B, C, and D. So that's what they're giving us here, these points. Now, the first method that we're going to look at is showing if the opposite sides are parallel, okay? Well, opposite sides here would be AB, CD. AB and CD are opposite sides, okay? AB and CD. And then opposite sides would also be BC and DA over here. Those guys would be opposite sides, okay? We have to show if those guys are parallel to each other. To first of all establish that we're even dealing with a parallelogram, because remember, opposite sides have to be parallel. So what we use here is we use our slope formula, m equals y2 minus y1 over x2 minus x1. And they're just taking the point. So in the first one, it says find the slope of AB. So if I'm finding the slope of AB, then this would be my x1, y1. This would be my x2, y2. So we're going to subtract our y's, and we'd have a -3 minus a -5. So a -3 minus a -5. Now remember, if we minus a negative, that turns into addition. Then we'd have 8 minus 2. 8 minus 2. Well, -3 plus 5 gives me 2. 8 minus 2 gives me 6, and we can divide a 2 from both of those, and we get 1/3, okay? So the slope there, if we actually plotted our graph and did the rise of the run from A to B, it'd be 1/3, okay? Now, its opposite side of AB is CD. We want to make sure that that's parallel. So we're going to look at CD here. That's the next one, the slope of CD. And if that's the case, we're changing, okay? We're changing what we're looking at in terms of our x1 and y1. So we'd have, what do we say? We're looking at CD. So we have x1, y1, x2, y2. Okay? So we'd have a -2 minus 0. That's what they show over here. Then 1 minus 7. Well, -2 minus 0 is a -2. 1 minus 7 is -6. 2 negatives make a positive, and of course we could divide out of 2 and we get 1/3. So notice, are my opposite sides parallel? Do they have the same slope? Yes. So we know that these two are parallel to each other. Okay? Now we also have to do the same thing for BC and DA. So we're going to look at the slope of BC. So again, I'm going to erase this part over here, and we're going to have a new x1, y1, new x2, y2. So this is now my x1, y1, and this is now my x2, y2. So we're going to have 0 minus a -3, 0 minus a -3, which turns into addition. And then we're going to have 7 minus 8. 7 minus 8. So we have 0 plus 3 is 3. 7 minus 8 is a -1. 3 divided by -1 gives me -3. So my slope of BC is -3. Now we also have to check the opposite side DA and see what we get there. So again, changing our x1, y1, x2, y2, okay? And we're looking at, let's see, DA, okay? So x1, y1, and then dx2, y2. So we'd have a -2 minus a -5. Oh, wait, they went backwards. They were going the other way. So let's go Let's make D our x1, y1, because I want to follow the same thing they're doing there. It's really not going to matter, but since that's what they're using, let's change it up. So we'd have x2, y2 over here. No big deal. So in this case, we'd have a negative 2, or excuse me, a negative 5 minus a negative 2, negative 5 minus a negative 2, which is changing this into addition. And then we have our x2, which is 2 minus 1. 2 minus 1. So a negative 5 plus 2 gives me a negative 3. 2 minus 1 gives me 1. Negative 3 divided by 1, we get negative 3. So are these opposite sides parallel? Yeah, because they have the same slope. So what we showed here is that these guys are also parallel. These guys are also parallel because they have the same slope. So now we know we're dealing with a parallelogram. We at least know that information. What we want to determine next is kind of looking at our slopes here. If we can look at our slopes and they're opposite reciprocals, okay? If they're opposite reciprocals between our adjacent sides, they would have to be perpendicular, okay? Well, look at this. Is 1/3 and negative 3, notice A, B, and BC, okay? Just so we're clear and on the same page, okay? A, B, and BC are adjacent sides. So we're trying to determine if this is a right angle. In order for that to be true, these need to be opposite reciprocals. Are they? Yeah, one is a positive, one is a negative, and if we flip 1 over 3, if we flip that, we get 3 over 1, which is 3. So these guys are opposite reciprocals. In other words, they're perpendicular to each other, and this would be 90 degrees. So now we know we're down to a rectangle and a square. The only possible way we can have our 90-degree angle here is we're down to it's either a rectangle or a square because we have 90-degree angles, okay? Now, after that, and of course you could see that relationship here too, they're perpendicular. I guess I should say you should look at both sides, just in case we're dealing with a different situation, but we're still have opposite reciprocals here. But after that fact, and we know we have 90-degree angles, okay, we also want to check to see if all the sides are the same, or if opposite sides are the same, but not necessarily all the sides are the same. So what comes into play here is the distance formula, okay? If you guys don't remember that, our distance formula, we take x2 minus x1 squared plus y2 minus y1 squared, and then we simplify, okay? So it's kind of similar. We have an x1, y1, x2, y2, but we're going to subtract our x and square it, subtract our y and square it, okay? So we want to look at side AB. Now, we could find length of all sides, but that's really not going to be the point here. We've already shown that they're parallel and that we have 90-degree angles. So we're down to a rectangle or square. Really all what we need to do is just determine if AB and BC have the same length. If they have the same length, we have a square, okay? Our length and the width have the same length. But if they're not the same length, then it has to be a rectangle, okay? So that's really all we need to do here is look at side AB and side BC. So what we're going to do is take A, okay, side A and B here, and we'd have x1, or we could even call this x2, y2, x1, y1, just to keep it consistent with what they have. And we'd have 2 minus 8, okay? 2 minus 8, subtract my x, then a negative 5 minus a negative 3. Remember, that changes to addition. And then we're going to simplify that. 2 minus 8 is a negative 6. Negative 5 plus 3 is a negative 2. Then square it. When we square something, that means times itself. Notice, a negative and a negative make a positive. So a negative 6 times a negative 6 is a positive 36. Negative 2 times a negative 2 is a positive 4. So we get the square root of 40. Now, for our purposes, we could try and see if we could simplify our square roots when we get down to it. We don't have to, as long as the square roots are the same, okay? Same thing with BC, okay? Same thing with BC. But let's just change this up and let's make this, we could call this, again, to follow what they have here, our x2, y2, and then x1, y1. Again, it's not really going to matter as long as you keep the subtraction consistent, okay? So if we subtract that, we'd have 8 minus 7, okay? 8 minus 7, negative 3 minus 0, and then simplify. 8 minus 7 is 1, negative 3 minus 0 is negative 3. Squaring both of those, 1 squared is 1. Negative 3 times a negative 3 is 9. 1 plus 9 is 10. so we get the square root of 10. Now check both of those. Are these the same? No. That means that the side lengths between AB and BC are different. If they're different, it can't be a square. In other words, we have a rectangle. Okay, so at this point, we now know that we have a rectangle. And that's what they say here, is that opposite sides we should have the same slope, so it's a parallelogram. Adjacent sides have negative reciprocals, or opposite reciprocals, you would say, so we know it had to be a rectangle or square. But after we showed that the sides are different, we now know it's not a square. This has to be a rectangle, okay? This shape has to be a rectangle, okay? Now that's method 1. Method 2, I know it seems like a lot of work here. Method 2 could be a little shorter, okay? We want to look at the diagonals. So if we're looking back at our shape over here, let's just kind of redraw it. We have A, B, C, and D. Now we're kind of looking at the diagonal. So instead, we're looking at AC, and we're looking at DB or BD. If we can show that those diagonals are the same, then it has to either be a rectangle or square. Now, if we know it has to be either a rectangle or square, then all we really have to do is repeat this step up here, which is show that the side lengths are different, okay? So let's just see if we can show if our diagonals are the same. So the length, the distance between B and D, that measure there, and then A and C. So if we take that, okay, let's look at erasing this guy, okay? And I want to follow the same process they have there. So in this case, they're calling this guy x2, y2, and they're calling this guy our x1, y1. Oh, not 2, y1, okay? So we're going to take 7 minus 2 in our distance formula, 7 minus 2, and then 0 minus a negative 5. 0 minus a negative 5, which remember turns it into addition. So we're just finding that length there of our AC. So 7 minus 2 is 5. 0 plus 5 is 5. And then we're squaring both of those. Well, 5 squared is 25 and 25, so we get square root of 50. So the diagonal AC is a square root of 50. Now, if BD is the same measure, then it has to be a rectangle or a square. Okay? So that's what we're doing next here. Okay? Is we're going to look at BD. Okay, BD. So, I mean, it really is a matter where we're going to subtract, because we're going to end up with the same answer here. But since they're starting with 8, I'm going to make this my y2, my x2, go back, x2, y2, and then my x1, y1. As long as you keep it consistent, you'll be fine. So we have 8 minus 1. That's what they have here, 8 minus 1. And then we have negative 3 minus a negative 2. Negative 3 minus a negative 2, which changes this into addition. So we have 8 minus 1 is 7. Negative 3 plus 2 is negative 1. 7 squared is 49. And negative 1 times negative 1 makes it a positive 1. 49 plus 1 makes 50. So we end up with a square root of 50. Now check these. Are these guys the same? Yeah, so we showed that this measure here is the same as this measure here. So it has to be a rectangle or a square, okay? Now, the second part of this process is exactly what we did up there. The same exact thing. We show that side AB and BC, they're either going to be the same and we have a square, or our adjacent sides are different and we have a rectangle. Well, since it's the same thing, we don't really need to rework it again. We saw that this was the square root of 40. We saw that this was the square root of 10. We showed that these side lengths are different measures. AB was longer than BC, therefore we had a rectangle. So that's the second method there. We knew we had a rectangle or a square, but since the side lengths are different, we have a rectangle. So that's method 2 using the diagonals.